about example of our achievement. So and summaries. So spintronics, this word is a keyword. So if I have a time, I like to give you my imagination for the generation beyond the spintronics. So spintronics,
Kayak gitu dia ngomong.
new word.
Kayak gitu
So,
dia ngomong. Kayak nggak pala jelas.
can I continue?
Tahu lah kalau yang kena
Yes, please. Udah sih, please continue.
Okay, so
dia masih jadi dana kampusnya, belum mulai penelitian.
is it okay? Can I continue? Yeah, maybe yes. Okay. Okay, so I believe everybody hear my voice. So spintronic, the new word of spintronics comes from the two origins. One is electronics. Electronics mean that diode and the transistors, that is only related to the charge of electrons. And also another origin is magnetics. So magnetics, daily life magnets are related, so made of the electron spin. Electrons, okay, I have to use a point. Okay.
Yes, udah sensei, please continue.
Okay, so magnetics. So magnet mainly come from the electron spin. So this spin, this word and the electronics together may, and then spin electronics. And spin electronics shorten, then spintronics appears. So spintronics main player is a spin, but combined with electronics, that is spintronics. So this is a daily life magnet. You can see, maybe you know the well-known, you well-known. This is refrigerators, magnet on the refrigerator in my house. So that is a ferrite magnet. So these kind of magnet can be used in the electronics. So that is spintronics. So important event or important things coming with this discoveries. So Professor Albert Feld and Peter Greenberg found the phenomena of giant magnetoresistance. So this is the data of the group, Professor Albert Feld. So magnet, so they apply the external magnetic field to the magnet, then they observe the drastic reduction drastic reduction of resistance. So this is a important issue to to develop the uh, hard disk drive. Hard disk drive. That is a very important discovery. Then they get the Nobel Prize in on physics in 2007. So people nowadays assign this event open the first generation of spintronics. That is the period of the first generation of spintronics. So hard disk important issue. So their discovery have been used here. So read out head for magnetic disk. Memory distributed, assigned on the disk. So this head worked with the GMR effect. So then 2007, another new technology emerging, appearing. So that is called TM 2007. is a computational science? One is experiment, observation. The other is a theory, but computational approach appearing and appears and become greater and greater. Nowadays, that is very important. I think the importance comes from the independence of the simulations. Independence. So ideally, independence from the experiment, independence from the theory. That is ideal computational science. Okay, so I try to. I don't have a time for the example of that. I think we have. I prepare some presentations in our group. So this is achievement of the chairman. So in Dr. Indra Pardete in Japan. So summary. So I think the spintronics, I think have a potential for future perspective, and density functional approach important in the computational science, and the computational characterization and control is maybe become important, and also I want to stress that collaboration with the experimental group accelerate material designs. So sorry, that's it. Thank you for your attentions. Thank you very much.
Okay, thank you, Oda Sensei, for the systematic presentation. So now the presentation is open to the audience. Please, if you have any question, please raise your hand and then ask question. For the first session, we open to the 2 questions. Okay.
Maybe I would like to ask a question to Oda Sensei.
Yes, please.
Okay, thank you very much.
For raising the questions.
Yeah. So thank you, Sensei. I am Anwar from Telkom University.
Yeah.
I was an assistant professor in Naras Hokuriku Sentang.
Yes.
Yes. I leave Japan in 2016 and returned back to Indonesia.
Oh, okay.
Yeah. So I am very happy to meet you here, and we are at the same sessions. And then I am also very happy to hear that you are making a presentation about spintronic.
Thank you. Thank you.
So actually I am very curious about the potential application in the future.
Yes.
Maybe I would like to know what is your opinion about the application, for example, in quantum computing or quantum communications. About this research.
Sorry, I don't have any idea or concrete any ideas. But spintronics utilize quantum technology, quantum mechanics. So I believe that such kind of Yes, you mean the quantum computer or computer communications.
Yes, yes.
I think the hardwares can be, I'm not sure, should be fabricated by the devices related to the spintronics. That is my imaginations. So sorry, I don't have any concrete ideas. But I think the spintronics technology should be used in the future technologies. I believe that spintronics technology has a potential in the coming 10 years or coming 20, not 20 years. I am not sure, 15 years.
Yes, yes. Actually, yeah. In some part, I agree with you.
Yeah, okay.
I also would like to introduce some potential technology for the 6G in 2030, and then some ideas are coming from the viewpoint of the quantum communications. That's why when you talk about the spintronic, oh, maybe this is a good chance to start the development for that kind of the potential technology for the future. Yeah. So yeah. So for me, it is a good viewpoint and also a good directions to develop
Yes, I
this
think so.
spintronics. Yeah.
I think so. I think that to reduce consumption energies, I think the people have to consider the combination with the superconductivities. That is one of the directions.
Yes.
So.
Okay. So yeah. So thank you, Sensei. So I am very happy to hear this presentation and also this
Okay.
this
Thank you
development.
thank you
Thank
for
you very much.
raising the many questions. Thank you very much.
Thank you very much.
Okay, thank you, Dr. Khalil Anwar, for the question. If we have one more question, please raise your hand and then ask the question. Okay. Okay, Oda Sensei, one short question if you have a comment. So now many students also join in this meeting.
Yeah.
And this method actually quite new for us. So then, do you have a short comment? What is the idea of your approach for calculated many property for spintronic application? Do you have one slide about the?
You mean you want to see the formula?
Yeah. Yes. I mean the idea. Can you say something?
Yeah. What we have to what we are doing. What we are doing is following. So I have only one slide because these are achievement or result, but what we are doing is solving. We are solving this kind of equation of motion for electrons. That this is a electron wave functions. So we solve the eigen problems, eigenvalue problems. This is eigenvalues. So this is the idea. So we describe the electronic state more accurately. So then we will get, and then after that, we calculate the necessary physical quantity by using the wave functions. That is ideas. So that is this set of the scheme is a density functional approach.
Okay.
So we take yes. So you can.
Okay, thank you, Oda Sensei. Yeah, we hope our student will
Yeah, that is.
interest
I
to
hope.
study this field in the future. Okay, again, thank you, Oda Sensei, for the kind and interesting talk.
Yes, thank you.
We hope we can make another meeting in the future.
Okay,
Okay.
thank you. So
Okay.
I diffuse share.
Yes.
No.
Yes, please. Okay, ladies and
Okay,
gentlemen,
thank you.
let us move to the second plenary speaker, Professor Khairul Rizal from Department of Physics, Institute Technology of Bandung. Professor Khairul Rizal, the screen is yours. Okay, so the second speaker, the title is Electrospun Nanofiber, Synthesis and Application in Various Fields. Professor Khairul Rizal, please start.
Okay. Could you see my presentation slide?
Yes, yes, Professor. Yes.
Okay, thank you very much. So, thank you, Mr. Moderator, Dr. Indra Pardede, and also thank you for the organizing committee for inviting me to this conference. And it is great honor for me to have this meeting today, although via virtual meeting, as I can meet with some colleges, also some students, yeah, here, and also some new colleges, yeah, from all over the world. And then I would like to talk about electrospun nanofibers, synthesis and application in various fields. Yeah. So if you want to see more about my research, you can also visit my website here, written here. So the outline of my talk is as follows. The first, I'd like to describe what is electrospinning. And then the next, I'd like to describe about electrospun nanofibers applications for water and air filtrations, functional foods, and drug delivery. Actually, this synthesis and applications we have done in our laboratory. Yeah. And then for the next session, I would like to describe about what we will do for the next, that is electrospun nanofibers applications for electronic devices. So about electrospinning apparatus. The apparatus is very simple actually. First, you have sirens here, and then you put polymer solutions, and then because the sirens has spinneret, which is a needle, metallic needle, and then some part of this solution can exit from this needle. And then because of we applied high voltage to this needle, and then we have another side that is a metallic collector, which is grounded, and then there is electric field from this metallic needle to this collector. We call this plate, this metallic plate is a collector. Because of that, and then some part of this liquid can be accelerated by this electric field. Because of these accelerations, we can see Taylor cone like this, and then a liquid jet here, yeah. And then this liquid jet travels toward to this collector, and then because of interaction with the environment, that is a temperature and a humidity, and then this tiny liquid can be dried and then collected on this plate. So because this apparatus is very simple, and then we have limitation in budget, and then we developed our system by ourselves as given here. Yeah, you can see here is this part. Yeah, this part, spinneret here. This is spinneret, metallic needle, and then this is collector here. But this is not a plate, but a drum collector, and then this is voltage plus from this high voltage power supply, yeah? And then some monitors to this process. So this part is a high voltage power supply that we developed by ourselves by using flyback transformer. This flyback transformers was from old fashion televisions. Yeah, we call a tube television. So we use this for developing the high voltage power supplies by controlling this low voltage input. And then because we know the ratio of this turn, and then we can control the output voltage. We can see the performance of this high voltage power supply as given by these two figures. The first is about voltage inputs as a function, high voltage output as a function voltage input. And then we have a parameter about the frequency here for, frequency is about 22 kilohertz, but duty cycles we change from 10 to 25%. We can have these curves. And then another figure is high voltage output as a function of voltage input. And then we fix the duty cycle about 16%, and then the frequency is changed from 8 to 26 kilohertz. And then we have this curve. And we can see by controlling voltage input from about 0 to 2 volts, and then we have voltage output about up to 25 or 30 kilovolts. So it is enough to control our electrospinning apparatus. And then we did some experiments to show the high voltage performance in obtaining the Taylor cone as given here. We can see if we increase the voltage, and then we have the Taylor cones becomes smaller. This is similar with the previous reports we have. And then this is the comparison we have. If we compare our high voltage power supply, yeah, by comparing with Matsusada, a commercial Matsusada high voltage power supply. And then for making this polymer solution and to exit to this metallic needle or spinneret, and then we have syringe pumps, and then by controlling this rotation by using stepper motor and some simple microcontroller, and then we can change the flow rate of this polymer solution, yeah, by using this system. And then another, this is the drum collector. This is just simple to make this rotation by using a simple motor. And then for the next is about electrospun nanofibers applications we did for water and air filtrations, as well as functional force and drug delivery. So you can see in our website here. Yeah. First is about nanofiber membranes. The flow by using nylon 6 nanofibers stacked over cellulose, yeah, cellulose. And then these membranes was used as a filtration, water filtration media. We can see here the stacking of this membrane. This is the nylon 6 nanofibers we synthesize over this cellulose membrane, which is from yeah, such as paper or some other form, yeah. And then we can see here the nylon 6 nanofibers, yeah, here. And then the diameter is less than 1 micrometers. It's about sub-microns, yeah. And then we can see here how this membrane can filtrate any some form in the water, like this one. This is a simulation for some pollution in the water, yeah. And then we can see here some secondary same image of the membrane after filtration, and then you can see further explanation about this filtration membrane by visiting this paper. And then another paper is about nanofiber membrane for air filtration media. This membrane was synthesized from expanded polystyrene. This expanded polystyrene is called as styrofoams. Yeah. And then this research was done by Dr. Abdul Rajak, which is one of Department of Physics ITERA staff member. So we can see here how this nanofiber membrane was synthesized, just cut into pieces some styrofoam or expanded polystyrene, and then diluted in the limonene and DMF, and then we have expanded polystyrene solutions. And then by using electrospinning apparatus and by changing some parameters, including flow rate, and also, as well as the voltage applied to the metallic needle or spinneret, and then some distance between metallic needle and the collector, and then we have some some images from the results. We can see here if we use 15% of the polymer solutions, and then we had a beaded fiber, but by increasing the concentration of the polymer solution, and then the fibers becomes smooth, smoother. And this is some filtration mechanism. If we use this membrane for air filtration media, so we have here some waste filtrated by this membrane, and then we can read further about this membrane by visiting this link. And then another application is about drug delivery. This is about electrospun nanofibers with antibacterial activity that synthesized from polyphenol, cellulose acetate, glycerin, and garlic extract. So we can see here some membranes, some electrospun nanofibers from this this polymer. Yeah, we can see the morphology, and then we can see also the cumulative release of the garlic extracts, from these fibers, we can see here. And then for further explanation or further description about these membranes, you can visit this link. And then another application is about also food, functional food. This is about functional foods. We know mangosteen pericarp extracts. This is very well known in Garcia, for example. We have also electrospun nanofibers from polyphenol pyrrolidone with mangosteen pericarp extracts, and then these are the same images of these nanofibers. And then we can see here, if we plot the mangosteen pericarp extract concentration with the fibers diameter, and then we can see here if the mangosteen pericarp extracts is increased, and then we have the smaller fiber diameter. And then this curve tells us about the release of alpha mangosteen contained in mangosteen pericarp extracts. This is this alpha mangosteen has many benefits for our body. So we try to have an experiment about the release of this alpha mangosteen. We can see here some curves from these nanofibers, and then this is our papers. And then beside, we can make electrospun nanofibers by using the same electrospinning apparatus. We can also make electrospray nanoparticles. just by changing the modes of this the experiments. Yeah? So these images, same images as about polyphenol pyrrolidone with mangosteen pericarp extracts nanoparticles. You can see here the particles, yeah. And then this is we try to make mangosteen release from this particle as shown by this curve, yeah. And then for these results, we can see in this paper, yeah. And then another electrospread spherical nanoparticles we have also obtained from our electrospinning by using turmeric extract with polyphenol pyrrolidone. In the previous slide, we have not spherical particles, but in this slide, we have quite perfect spherical nanoparticles from electrospread modes of this apparatus. Yeah, we can see here. And then this is for functional food. So this is the antioxidant activity of this turmeric extract contained in the polyphenol pyrrolidone. Yeah, we can see here. Yeah, this is a turmeric ratio with polyphenol pyrrolidone. Yeah, so we can see if the turmeric is increased, and then antioxidant activity of this spherical nanoparticles becomes higher. So for further information about this experiment, you can see in this link. And then another other slides is about electrospun nanofibers applications for electronic devices. We are in progress in doing such a kind of experiment, but in at our present presentation, I try to show you some application made by other researchers. So the first is about electrochemical sensors. The important parts of electrochemical sensors is a light itself and then the receptor. So we have to synthesize the receptor, because as transducer is like some part of electronics as well as amplifier. Yeah. So we focus on this analyte and receptors. So there are three types of electrochemical sensors. The first is amperometric, second one is potentiometric, and the third one is voltammetric. And many sensors are based on amperometric. According to the different modifiers of electrode materials, yeah, electrochemical sensor can be separated into two classes. The first is about enzyme sensors, and the second one is non-enzyme sensors. Yeah. So why we choose electrospun nanofibers for enzyme electrochemical sensors? Because electrospun nanofibers have characteristics of high porosity, large specific surface area, and good interconnection, proving their excellent ability to immobilize enzymes. So the electrospun nanofibers functions as to immobilize enzymes. This is the example of glucose sensor given by this paper. We can see here So the important part for for sensing glucose is here. Yeah, glucose oxidase. This is the enzyme, yeah, to sense glucose. So to immobilize this glucose oxidase, we prepare a clean gold electrode, and then we put some 4-ATP amino thiopenol, yeah, self-assembly modified electrode. We can see here some pillars here, and then in these pillars we synthesize this electrospun nanofibers consisting of PVA, polyphenol PA, and then polyphenol alcohol, ethylenamine, yeah, and glucose oxides. Yeah, we make a mixture of these polymer solutions and glucose oxidase enzyme. Yeah, and then we have this nanofibers, and then we put some gold nanoparticles. Yeah. Okay, and then it becomes glucose sensor. Another glucose sensor is given here, I think. Yeah, like this one. Yeah, the same. Yeah, just part of this nanofibers.
Professor Khairul,
Yeah.
I'm so sorry. You have 2 minutes more for the
Okay.
Yes.
Thank you very much. And then we have another glucose sensor. So the important part of glucose oxidase is to immobilize this enzyme into these nanofibers like this one. Yeah, this is another peroxide sensors. Yeah, by using electrospun nanofibers and then doing carbonizations, yeah, and then becomes these sensors. And then another enzyme non-enzyme electrochemical sensors, we use just some metal, yeah, some metal as given here. And then these metals, yeah, these metals is included in these fibers, yeah. And then we can see in this report. Another peroxide sensor, still we use platinum metallic metallic sensor for sensing this peroxide. And then this metallic sensor is included in this nanofibers. Yeah. Another is about for transistors, just to replace the channel of these transistors. Yeah. We have nanofibers for the channels. This is also for the channels, yeah, for this thin film transistors. Some wearable sensors here, yeah, by using these nanofibers. Okay, nanowire FET. I think that's all. Thank you very much for your kind attention.
Okay, thank you very much, Professor Khairul, for the very interesting talk. So we can see homemade apparatus meaning can provide us many results and can be applied for some application. Okay, now the presentation is open. So please raise your hand, and if you have many questions, let us know. In this session, we open for 2 questions. Okay.
Yeah, feel free to have questions.
Okay, Professor Khairul, I have one question about your presentation. So, do you have comment? What is the current situation? I mean, the current progress from the result of the electrospinning technique?
Yeah, the electrospinning technique is the simplest technique for obtaining nanofibers. So that many applications we can have by using this technique, as we showed you in some current examples, yeah, because we can see in the publication. This is just a very recent publications in journals. This is yeah, I think that's all.
Okay, please, if you have questions, comment. Okay, if not, let us close.
I have question.
Okay, please.
I have question.
Yes, please. Yes, please, Professor Mitra Jamal.
Professor Karija is very interesting. As you know, the problem, especially in Sumatra, we have problem with water. It is possible to use the raw material for filtering the water, especially from gambut.
Okay. Thank you very much, Professor Mitra, for your questions. It's very interesting. How to make a filtration about gambut, yeah, gambut. Yeah, I think that still there is a possible application of this nanofibers for filtration. I think it's better as this filtration. I think Dr. Abdul Rajab has experience in filtration, although his doctoral thesis is about air filtration, but it is quite simple to change into the water filtration. The problem is that maybe first we have to separate some particulates. I mean the bigger particulate first, because we have these very tiny nanofibers, and then maybe by using these nanofibers, the step of using these nanofibers is about for the last filtration. Yeah. So we maybe we have to make some stack of the filter for the harsh and then for the fine filtration. I think so.
Is there an example for that this filter is used in other country or
No?
Not yet.
I think for gambut is very specific to Indonesia.
Thank you very much.
Thank you.
Okay, time is coming, so we can continue in another session. Thank you for Professor Rizal for the very interesting talk.
Thank you very much. You're welcome.
Okay, next we move to the last plenary speaker. The talk will be given by Associate Professor Koiril Anwar from Department of Engineering, Telkom University. Okay, the title is Advanced Telecommunication Infrastructure during Pandemic COVID-19, MCRBR, and Open RAN for 5G, 6G. Associate Professor Khairul Anwar, the screen is yours.
Okay, thank you very much, Pak Pardede, and thank you very much to the committee. Good afternoon, everybody. My name is Khairul Anwar, University Center of Excellence for Advanced Intelligent Communication in Telkom University in Indonesia. And I am also the Vice Chairman of Asia Pacific Wireless Group, where the office is in Bangkok in Thailand. And currently I am the Chairman of the Professional and Continuing Education activities in IEEE Indonesia sections. So I'm very happy to meet you everybody here. We are now having about 200 participants, including myself. In this about 15 minutes, I would like to introduce and also provide some directions about what should we do. So in the next 10 years, about 10 years, and also what should we do in this pandemic COVID-19. So I provide the title here is the Advanced Telecommunication Infrastructure. So I would like to make a good match with our conference. Our conference is Infrastructure, Technology, and Regional Development. So I try to introduce our research about the telecommunication infrastructure, especially during the pandemic COVID-19. That is the MCRBS. Yeah. MCRBS stands for the Mobile Cognitive Radio Base Stations, and also the Open RAN. Open RAN stands for the Open Radio Access Network, especially for 5G and 6G, where 5G we will have soon in Indonesia, maybe in 2020. 2020 is the trial phases, and then 2021 or 2022, I do hope that we can enjoy the services of 5G, and then the 6G will be in 2030. So I do hope that this presentation will provide you with some trend and also some current results, especially from our laboratory to the development of science and technology. So everybody, I completed my bachelor in ITB, and I was working in PT Astragrafia Information Technology in Jakarta, and then I was studying Japanese language in TIT, and I got my master and PhD in Nara Sentang or Nara Institute of Science and Technology, and I was the assistant professor in JAIS in Ishikawa since 2008 until 2016, and then I returned back to Indonesia in September 2016 until present. So I do hope that it is a good chance for us to make discussion and sharing the knowledge about how can we develop technology for Indonesia and also for the world. And before I start my presentation, I would like to introduce that our university, starting from this July 2020, we are recognized as the number 14 TIP lab. TIP stands for the Telecom Infra Project Laboratory. So we are the last member of the TIP lab, where the first is in Madrid in Spain, sponsored by Telefonica, and then the second is in London in UK by Facebook, and the third it is in UK also. And then finally, I think in Japan, we have KDDI, I think. Yeah, in Japan, in Tokyo, sponsored by KDDI. And then the last in Bandung, in Indonesia, sponsored by Telkom University. So this is, currently we are the latest member of the Telecom Infra Project, where we should make contribution on the development of the currently 5G, especially 5G based on the Open Radio Access Network. So everybody can see from this map that our logo of university is here, and Japan is here, and some laboratory in the world are shown in this map. So in this time, I would like to also to invite everybody who are related to the development of 5G and also 6G to join our laboratory, because I think we will receive many contribution from the world, and we have a large community in the world, so that we can develop this technology for Indonesia. and also the word, inshallah. And this is our target for Indonesia. So the TIP in Indonesia. So we have the 5 pillars of actions. So the first, okay, before I talk about the pillars, so it is our core community, Telecom Infra Project, and GSMA. This is the association of the all operator in the world for mobile communication, and then Kominfo, Bakti, Telkom University, Telkomsel, 3, Indosat, XL, and also Smartfren. And we have also the community group here. So the first, our job to test and validate the TIP open technology in the TIP community lab. So this will be in Bandung, and then we will make announcement, and then I to hope that we can invite everybody who are joining this conference to our TIP lab. And then after that, we should prove the solution in the field. So we should make the real field experiment, especially for Indonesia. And then after that, we set the platform for building the awareness through the events. So we'll make an event to show the some result, and then also the build the local talent pool of the community. And then the last, we are expecting that we can accelerate the startup, the development, and also the local players. So this is our job of the development of telecommunications in Indonesia via the TIP International TIP Lab, where we are number 1 in Southeast Asia currently. And then, okay, everybody, before we talk about what is the trend of the future direction, let's discuss what is the problem. So telecommunication, especially the information and communication technology, or ICT, for rural areas are urgently needed for education and communication during this outbreak of the pandemic COVID-19. Especially we are having many blank spots in Indonesia. So what kind of our contribution that can be provided to help them? The second, this is the prediction by the GSMA released in July 2020 that ICT development for rural areas is expensive. So I do hope that we can reduce the cost and provide the good service for the community, for the citizens. And then the prediction of the GSMA is that 5G is predicted only 5% in Indonesia for 2025. So according to my opinion, this is too small. So I think we need more contributions, from the researchers and also from the industry to accelerate the deployment of the 5G in Indonesia. And then Indonesia will only be the big market of smartphone in 2025. So I do hope that this is actually the problem for us. And then we need more contributions from the community, from the universities, from the industries, to develop this, such that we can provide contributions and we can be also the good player to our countries. So this is 3 problems that we are facing during this pandemic of COVID-19. And then we are proposing to solve this problem by using 4 technologies here. The first, we in our laboratory, we propose the use of the MCRPS. M is mobile, C is the cognitive, and R is the radio base stations. So this is actually we developed after the disasters. So actually we developed this before the COVID-19, but we developed this for the disasters and to help the victims. To help the victims, because after the disasters, maybe their mobile phone is still active, but because of the lack of the power of the existing the base stations, and then they cannot communicate with another network or with another partners. So we propose to use this, to replace the broken or the destroyed base stations due to the disasters. So we developed this before the COVID-19, but after the COVID-19, since February or since December last year, especially in Indonesia, we start to make the working from home in March 2020. So we are thinking that we can modify this for the blank spot in Indonesia. So currently, we will go next month. We will go to Papua to provide this in Papua. So especially we can. What is the new thing in this part is that we can serve the 2G, 3G, 4G, and 5G at the same time using this device. And then the second is I would like to invite all researchers in Indonesia that maybe in our country we need to develop the OTH. OTH stands for the over the horizon communication. So we use the ionospheres here, we transmit here, and then we can reach very far away the part of Indonesia. Because I think we can use satellite, we can use the hubs, but we need more, the third, that is this one. Originally, this is the old technology, but with the touch of modern science, maybe we can develop this one. So I would like to invite all researchers to develop this together to our country. And then the third, currently we are developing the next generation of the Internet of Things, where the current Internet of Things technology, for example, using the pure Aloha, the throughput is very small, 0.18 packet per slot. And then, for example, using slotted Aloha, increase about twice, 0.37. But what we did in Telkom University is that we can increase into 0.9 until 3.7 packet per slot. So we are proposing the new concept of the multiple access technique using the coding scheme, especially based on the low density parity check code for the multiple access scheme, such that we can increase the throughput significantly, about 10 times compared to the NB-IoT, from 0.37 into 3.7 packet per slot. We have published this result in IEEE transactions in 2016, and then currently we are going to the next step, that is to make the proof of concept using the real hardware. And then the technology number 4, maybe we can introduce to develop or to solve that problem, is that using the open radio access. So with this open radio access, we can avoid the domination of the operator. So usually in the conventional technique, in the conventional generation of telecommunications, hardware and software are united. But starting from 5G, actually starting from 4G, but a small part of 4G, and then we spare it between hardware and software. So due to this separation, I think the local company, the local industry can join to develop the 5G for Indonesia, because it is urgently needed. Our country is very large, but we need fast technology that can serve them. So this is our 4 solution to solve the problem of Indonesia currently. And then, Pak Pardede, how long I have the time? I still have about 10 minutes?
10 minutes, yes.
Okay, 10 minutes. Okay, I will try to complete my presentation within 10 minutes. Okay, everybody, let's see this slide. So in this slide, I would like to show the development of 5G, the development of the telecommunications, which is almost every 10 years. Currently, we are in 2020, so we are having 5G here with the name of the NR. NR stands for the new radio, of which the speed is until 20 gigabit per second maximum. And then in 2030, we will be having the 6G. The 6G here, we do not specify the name yet, because I think the standard will be released in 2025. But the target of the 6G will be more than 1 terabit per second. So it means that I think the human will be served by the telecommunications lot. And then what is important is that the human here, the human generation is also changing. This is according to my observations. This is I am also inviting a researcher from the social science to study this one. Maybe the technology has the impact to the social, maybe, because baby boomer generations and X generation, when they are young, they don't have the mobile phone, right? Because the 1G started from 1980. This impact to the Y generations until 2000s. So 1G and 2G impact them until 2000s. And then 3G impact Z generations until 2010, until 4G. We have 4G with the name of the long-term evolution here. So we do not know the impact of the 5G for the, I don't know, generation here. I just give the name beta here. Maybe the name is beta or another. So please also make a research. What is the impact of this to the generation? We are expecting that the technology will not provide the negative impact to the society. Okay, so the next is that the band, the probability of band that we can use for telecommunications. Currently, 2G, 3G, 4G, we are using this band. So below this microwave, below this 30 gigahertz. So at the left-hand side here. Using this band, you can reach a long distance, but it cannot reach Indonesia as a whole. That's why I am proposing the OT8. Just maybe 5 kilometers, we're using this band. And then 5G will be using the millimeter wave. Yeah, 5G is divided into sub 6 and beyond 6, that is starting from 24 gigahertz. So we will have the millimeter wave until 100 gigahertz here for 5G. And then 6G, we will be starting from the terahertz band here. And then I don't know, 7G will be in 2040, maybe using more than this. Yeah, but we cannot use this band because this band is dangerous. So the band before the visible light, it is dangerous. So I think that the scientists will not use this for telecommunication. So the maximum band for telecommunication is below the visible light. So when you see that the 5G, the hoax of 5G, the 5G caused coronavirus. So this is definitely, I think it is not correct if we follow the standard of the 3GPP, for example, or ITU, and then the radiation of the telecommunication will be also not high, and the band is still very safe band here, not the dangerous band in the area here. Okay, so this is technology number 1 because my time is limited. I just want to show that MCRBS is applied as like this. So after the disaster happens, then we release the mobile cognitive radio base stations to help the victims here, such that they can communicate to ask for help. And this is also funded by the ASEAN project. So we receive also the funding from the ASEAN to develop this together with the drone to help the victims. And then this is our result of the current results. This is the experiment of the first phase. Yeah, that everybody can see here that our mobile cognitive radio base station is mounted at the backside of the car, and we are expecting that this will be the car of the BNPB in Indonesia or BPBD in Indonesia. And then everybody can see the antenna, the antenna on the top of this tower. This can receive the 2G, 3G, 4G, and 5G at the same time. And then we have also tested here that we can successfully make the connection from the mobile cognitive radio base station to the existing mobile phone. And then we will be bringing this technology to the Papua next month to help the educations there. Okay, this is our possible design in Papua. So I am also inviting everybody to develop the technology to help the blank spot in the area of Indonesia. Maybe if we cannot cover the whole, but we can cover some of them. So this is the possibility using satellite or using the over the horizons communications. But if the location is not so far from the city, maybe we can use a relay or we can use the microwave link. So this is possible network design using that MCRBS. And the second is that using over the horizon communications, So according to some research, yeah, this is that it can reach about 2,600 kilometers away from the transmitter. It means that I also check here from Badung to Sumbawa, it is around 1,500 kilometers. I think we can reach Sumbawa with one loop of the OTH. But for this technology, yeah, this is still the old technology, but we need the touch of the new technology, especially for possibility of using broadband communication using the OTH communications. And then the third, this is our technique. We publish this in some IEEE conferences and also some journals, that we can reach the limit of the next generation of IoT. And this is we developed when I was in Japan, and then I bring this to Indonesia and further develop this in Indonesia. And then technology number 4, this is the Open RAN. As I explained before, that since we can make the separation between hardware and software like this, so hardware and software is separated like this, then many companies can join. So for example, company A, B, C, they can join to develop the Open Radio unit, and vendor, for example, 1, 2, 3, 4, they can also develop the software. So with this Open RAN concept, I am expecting that the Indonesian startup company, the Indonesian industry, yeah, they can provide us, they can participate in the development of 5G and also 6G. And then this is the possibility of the coexistent 5G and not coexistent, sorry, the joint network between 4G and 5G. So this area is 5G and this area is 4G. Yeah, so this is the typical architecture for the 5G using Open RAN. So we are separating the RRU, TU, and central unit here. And then this is also possibility of the development that maybe if some industries are joining this conference, so we can, you can see here that it is actually can be made by the Indonesians. But we need collaboration and also the funding maybe. But by joining our TIP lab, yeah, we are expecting that we can help each other to develop the 5G for Indonesia. And this is the some typical results of the currently produced of the Open RAN equipments in the world. So this is macro, antenna, mini macro, small cell until the FEM2 cells. So I think we in Indonesia can also help to develop this for our own countries. And then this is, I took this from Rakuten in Japan. So everybody can see here that the base station for 5G is very simple. You can just take a monopole and then put the RRU here, yeah, and then you can deploy the 5G. So by doing this, yeah, we can make the cost reduction because the cost is significantly reduced. So we are expecting that we can provide the cheap technology for Indonesian masyarakat, for the Indonesian citizens. Okay, so everybody here, because my time is limited, so I will try this very fast. So this is 4G, 5G, and 6G. So you can see here, the big difference is that in 5G, we have more use case. And then you can see here, the big difference is the intelligent. So in 6G, we will have the intelligentization, but in 5G, not yet. And then also the target is more than 1 terabit per second. And then we will be using the terahertz communication and using supermassive MIMO here. And then what is important, as I asked to the Oda Sensei, is that the quantum communication and computing and also artificial intelligence and machine learning will be the main part of the 6G in 2030. So we are expecting that with this one, yeah, we can make contribution to the development of the 6G in 2030. And this is the taxonomy of the deep learning for communications. So the artificial intelligence inside of them is the deep learning, yeah, can be applied, yeah, from the physical layer until the network security. So I think a big chance for us to make development here. And then the last, we may apply the 6G and also 5G for Indonesia, especially for the deep sea sightseeing. And then because we are having many beautiful sea in Indonesia. So I think that we should exploit them using the technology. And then the wireless capsule endoscopy that we can develop for the human. And then this is actually my idea. I do hope that some industry in Indonesia can develop this. This is the virtual reality, yeah, and also augmented reality maybe, that we can develop for manasik haji. Currently, when we are studying for the Hajj, we make the human made of the Kaaba. But maybe with the virtual reality, we can use this to study almost real, yeah, almost real, such that we can also feel and we can view what is happening, and what kind of situation in Mecca and also in Medina. So this is maybe a good technology for Indonesia. And then we are also currently develop the channel coding for molecular communication for drug delivery. But this is the initial state of our research. So I think this is also a good chance for researchers in Indonesia to develop them. And finally, as the conclusions, the problem of the developing countries are in general larger compared to the developed countries, especially in rural areas. The telecommunication network are urgently required during the pandemic of COVID-19, yeah, causing those students are suffering from the difficulties of the online class. And then OTH exploit the old technology, but with the new touching of modern technique, for example, OFDM or relay with decoding, we may make this modern and useful for Indonesia. And the disaster risk is possible to be minimized using IoT and also the MCRBS based on 2G, 3G, 4G, and 5G communications, and also including 6G maybe in 2030. And then managing inhabitant islands and deep sea sightseeing is possible with almost zero power 6G communication supported by the artificial intelligence. Okay, everybody, so this is all from me. I do hope that it can motivate us to make more contributions to the science and technology and also to our country. So thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much for the very interesting talk. Now the presentation is open. We have 4 minutes for question and answer. So please, if you have a question, raise your hand. I see some lecture from Department of Electrical Engineering, Institute Technology Sumatera here. So please.
I have a question.
Yes, please, Professor Mitra Jamal.
Thank you, Dr. Khairul. It's very interesting. I see that for 5G, you see that for Indonesia, just 5%. Could you tell us what's the big problem about the technology or the funding?
Yes. Okay. Thank you very much, Prof. Mitra Jamal, for the questions. Yeah. Actually, the first, I also got surprised why the GSMA predict that 5G in Indonesia is only 5%. Yeah, the first, according to my opinion after reading that one, is that when compared to other countries, so we are still facing the problem of the frequency or the band for 5G, because the current existing band, it is used by the traditional technology, so we have to move them first. Yeah. Okay. So this is the first problem. The second problem is that we are not having the strong industry that we can make a radio unit by ourselves. We are still depending on the industry abroad. So our country is very large, but we don't have a strong industry, and then we are depending on the import from other countries. So this is maybe the second reason why only 5%, because maybe other countries, they also focus on their own countries, or maybe they focus on another developed countries first, and then after that our country. So motivated by this problem, actually, with this presentation, I would like to invite many researchers in Indonesia, especially from the electrical and electronic department, to develop this together, and also to industry to develop this together. Maybe for the first step, it is, of course, this is difficult. Of course, it's difficult. So for the first step, maybe it is not so excellent. It is fine, but we can improve year by year. and then we can cooperate with industry outside. This is what currently I am doing, is that I make the joint research with Qualcomm and also with Nokia and also with some industries abroad, for example, with Altiostar or with another industry. So we do that by the TIP lab. So from the TIP lab, we're expecting that we can increase the percentage of the local, the local production to the actually TIP lab here. It is a very good chance for us to start making by ourselves. So by doing that, I am expecting that in 2025, we can reach more than 5, maybe 10%, or maybe more. So those two problems, Pak, in our country. Yeah, thank you very much.
I think that's the opportunity for Telkom to more.
Yeah, yeah, Telkom and many other universities, including ITB, including ITERA. Yeah, so we are welcome to make cooperation, Pak, joint research and also the joint project, for example, to make this real for our countries.
Yeah, ITERA is interesting to make cooperation for this.
Yeah, sure.
Thank you very much.
Thank you very much, Pak.
Okay, because time is limited, so please, if you have any question, please directly reach to Dr. Colin Anwar.
Thank you very much.
The join for some joint research.
Okay.
So, okay, this is the end of our session. So again, I want to say thank you very much to our plenary speaker, Professor Tatsuki Oda, and then Professor Khairul Rizal, and also Associate Professor Colin Anwar, and to all participants who joined with us in this session. We hope we can meet again in another meeting. So thank you very much.
Okay, thank you very much.
Okay, and for the next session, we'll start 15:20. So please, if you have time, let's join to the second session. Okay. Thank you very much.
Thank you very much.
Okay, thank you very much.
Good afternoon, ladies and gentlemen. I think my voice is heard by all of the participants, right? Welcome to the second session of the plenary speakers of the ICOSITER 2020. My name is Dr. Weni Arminda. I'm a lecturer in Department of Architecture in the Institute Technology Sumatra. I'll be the chairman of this session. Okay, in this session, we will have 3 plenary speakers. Firstly, let me briefly introduce the background of our speakers. The first speaker is Professor Peter van den Broek. He is from KU Leuven, Department of Architecture, PND Research Unit. He is the Assistant Professor, Tenure Track, Faculty of Engineering Science. Okay, here, his research topic including spatial planning, social innovation, sustainable territorial development, commons, land policy, and critical institutionalism. Okay, the second speakers, we have Professor Hiroatsu Fukuda from the University of Kitakyushu, Japan. He obtained Doctor of Engineering from Waseda University, Tokyo in 1995. The employment history of Professor Hiroatsu Fukuda is from 1994 to 1996. He becomes the assistant in Waseda University, Tokyo. In 1996 to 2000, he is a lecturer in Waseda University, Tokyo. In 2000 to 2007, he was the associate professor at the University of Kitakyushu. And since 2007 till now, he is the professor at the University of Kitakyushu. His research interest is low carbon architecture and urban design, environmentally friendly architecture design, symbiotic design made of Japanese cedar, robotic and parametric architecture, building thermal evaluation. Professor Hiroatsu Fukuda is also a membership of the First Class Architect, GIA, the Japan Institute of Architects, the Council of Tall Building and Urban Habitat, the Asian Institute of Low Carbon Building, and in collaboration with Meldia Institute for Advanced Wood Laboratory. And our third speakers, we have Dr. Muhammad Al-Azhar. Dr. Al-Azhar joined the Plymouth Marine Laboratory, or PML, as a marine ecosystem modeler in December 2018. His main research interest is development and implementation of coupled circulation and biogeochemical ocean models to investigate plausible impact of ecosystem change to the marine environments under the present day and future climates projection. Prior to joining PML, he was the postdoctoral associate at the New York University, Abu Dhabi from 2015 to 2018, where he simulated a role of seeing organic carbon in generating the contrast strength of low oxygen waters between the Arabian Sea and the Bay of Bengal in the northern Indian Ocean using the coupled models. There, he also modeled a recent trend of low oxygen volume in the Arabian Sea, as well as simulated impact of atmospheric deposition to the primary productivity in the basin. Additionally, he implemented an operational ocean model in the Arabian Persian Gulf that was applied to track oil spills and algae blooms, even when he worked as a postdoctoral scientist in Masdar Institute, Abu Dhabi from 2014 to 2015. All obtained his PhD from the University of Copenhagen from 2013 with a focus on the coupling between nitrogen, phosphorus, oxygen, and sulfur cycle in the regional ocean model. He applied the development model to understand the importance of shelf-ocean exchange for the development of bottom water anoxia associated with different continental shelf geometries. All right. Without any further ado, I would like to tell the rules of this presentation. Okay, each speaker has 20 minutes for the presentation and followed with the Q&A session. I will open for the two questions. And for the participant who wants also give a question to our speakers, please leave your question in the chat column and mention or state who the question is addressed to. All right. I will call upon our first speakers, Professor Peter van der Broeks. You may share your screen.
Okay, thank you. Let's hope
right.
this is okay. Can you hear me?
Yeah, sure.
Okay, great. And can you see my presentation?
Yes. Professor Peter van der Broek will deliver his presentation entitled From Techno-Economic to Social Innovation. The screen is yours, Prof.
Okay, just a second. Okay, you can see it well? Okay, great. So first of all, I want to thank the organizers for inviting me to the ICOSITER conference and for giving me the opportunity to talk about a topic that might be a little out of tune, but which seems to me still highly relevant for the conference. In my intervention today, let me just put the timing here. In my intervention today, I will address the topic of social innovation. I will argue that, in my view and in that of my colleagues, innovation is much more than creating new ways of doing things in order to stimulate economic growth, but that it is necessary to deconstruct and broaden up the notion of innovation and to link it to development, to governance, and to the ways people collaborate. Rather than seeing innovation as merely instrumental to economic growth, development through social innovation should be a goal in itself of local, regional, national, and international practices and policies. For this presentation, I draw extensively from the work of Professor Emeritus Frank Moulaert, my predecessor in this department, since he is one of the few that who since 30 years has been formulating a critique to a rationalist, instrumentalist, and economistic understanding of innovation. He reintroduced the concept of social innovation and since then studied how bottom-up initiatives are capable of triggering social innovation and social political transformation. In our research group, we continue working on this in dialogue with other research units in Europe and in the world. So let's start by looking at what is innovation. There are many definitions of innovation, but most of them have been given either from a practical perspective, for example, looking for a solution to a recurrent practical problem or a challenge, or from a rational systemic perspective, which means building a system with relevant agencies allowing to lead an invention to fruition. And both are sometimes combined. However, in order to understand what innovation is and how it works, we believe that you have to contextualize it. You have to put it in its economic, social, cultural, and political context. You also have to translate it into concrete human behavior. After all, it is humans that innovate, or not. And humans are creative, but remain limited and focused in their aspirations and agency. They're specialized, they're creative, but not economical. They might be humanly warm or supportive. They might be cold or fishy persons. Also, across contextualization, we should take into account space-time dynamics. We should take into account history and geography more particular. Why do we look at innovation among other human ambitions? In contemporary society, and especially since positive sciences have in many respects overruled the human and the social sciences, progress is almost automatically linked to or translated as innovation. So new products or production processes, new rational and efficient modes of organization of human life, etc. In the systems of innovation literature, many scientific and policy models have instrumentalized culture to the benefits of this view of innovation. thus often canonized a one-to-one correspondence between innovation and development. Recently, innovation as a concept and as an agency has been deconstructed, or should we say humanized again. The work of Godin and his colleagues is important here, looking at de-innovation, reverse innovation, innovation by introducing the old back again, etc. And development has slowly rediscovered its right to think in terms of human development. Let's have a look at community development, local development, and so on. For that understanding, we need to look at the history of innovation literature. Again, referring to Godin, but also to our own work and people like Frank Moulart, Bob Jessop, and so on, we argue that innovation theory and practice, when it started flourishing among academics and later on among policymakers, had lost touch with the history of thought and practice of innovation. Moulart's work on territorial innovation models and spatial innovation stirred the necessity to look back at this history. The following figure shows how the meaning of innovation evolved from social, political, and religious to only technological innovation, which was only coined in the 1930s, and as such, taking it out apart from its relationship to evolutionism and the more routine concepts of institutionalism. The figure, for example, well, I will not go into detail here. I take this figure from a European report exploring the roots of the social innovation thinking from going back to the end of the 18th century and showing how it evolved from a rich understanding of cultural, social, economic innovation into a reduced form of technological innovation. If we then look at the relationship with development, we have to come back to innovation and the regional. In our team, we did a lot of research on how the reading and practice of innovation should be opened to their original plurality, as I also showed in the previous figure. We especially focused on social innovation as a correction or even an antithesis to technological and organizational innovation, which we considered for many reasons as too rationalist, too oriented towards the market-oriented world, the market economic world, too systemic and therefore unrealistic about the profoundly irrational, creative, spontaneous, etc. features of the human being and its social relations. The following two slides give brief examples of how innovation approaches to spatial development can be opened up to human and community views of human development, thus giving social progress and community development predominance over competitiveness and economic efficiency. Other alternative approaches to spatial development and regional development are emerging. The social region, for example, literature on alternative food systems, social ecosystems, and so on. I show here one figure without, again, going into detail from the literature on integrated area development, making connections between social innovation, culture, institutional dynamics, the role of grassroots movements, and a broad perspective on economic development as socio-economic development. Another example of broadening the view of technological development to technological innovation to social innovation is our work on spatial quality, showing and analyzing how stakeholders define, negotiate, and co-construct spatial qualities, showing how the spatial is social and how the social is also spatial. If we then go to defining more or less what is social innovation, we have to start from many examples. Looking at social innovation means looking at new types of social relations in firms, corporate social responsibility, social enterprises, social cultural initiatives, new, more horizontal forms of governance, democratizing initiatives that give access to culture and giving recognition to popular culture above elite culture, and so on. But more fundamentally, we argued that social innovation is about building and rebuilding social relations for human development. It is also about prioritizing innovation in human relationships to innovation in technology and organization. The latter should be functional to the first, which we argue. I refer here to a critique of Frank Moulart and Secchia on territorial innovation systems, where the opposite is happening, where the direction of the instrumental relationship from culture to economy is reversed. In the end, real economy is for humans. The definition of social innovation, which we then use in our networks, rests on three interconnected pillars. The collective satisfaction of unsatisfied or, well, less satisfied human needs for all, including the underprivileged. Innovation in social relations and therefore power relations and governance systems. And third, socio-political empowerment. This definition starts from a dynamic perspective on how communities and groups pursue the improvement of the quality of their existence within a potentially transforming socio-political system. It is a grounded definition, grounded theory definition, which means that we base it on participatory observation in urban neighborhoods and other local places starting in the late 1980s until now. Yet, using the analytical categories offered to us by social sciences. These case studies include research, I'm just very briefly mentioning a few, on, for example, the upper left, community archaeology in Turkey, the empowerment of prostitutes and neighborhood development in Belgium, the middle left figure, community-based sanitation in Indonesia, lower left, alternative housing provision in the United States, the upper middle figure, community land trusts and empowerment of traders in Kenya, the middle figure, social housing in Brussels, the right figures. But many other examples are possible. And these type of examples can be found in many publications, some of which to our group also contributed to. For example, the International Handbook of Social Innovation collects the upper left image, collects numerous examples of various locally inspired initiatives and how they transform the existing social relations. But many other books, as I show here, exist and are available. To more or less go towards the end, I want to highlight the consequences for policy of this approach, but I will only pick one element or very few elements here. Starting from a reference to the book of Karl Polanyi in the 1930s already, 1940s, the book called Great Transformation, where he showed how through the rise of liberalism in economic practice and policy making, the equilibrium between economy and society was broken. Using anthropology and socio-economic history, Polanyi especially showed how very recently, let's say the last 200 years, markets evolved from mere instruments for economic activity and the allocation of resources to all-encompassing systems in which also humans and nature themselves were gradually commodified. Today, both conservative and progressive critics of neoliberalism have a similar message. Contemporary economic policy is primarily oriented towards profitability and the expected multiplier effects in terms of, for example, job creation that supposedly result from improved competitiveness because of innovation is an old tune, but it is also a basic economic myth, we believe, that does not work without a multifaceted redistribution policy. And redistribution today has become a curse word among technocratic policymakers who often are lacking basic training in macroeconomics and macroeconomic policy. So how can regional policy then play a role in restoring the balance between economy and society? Macroeconomic policy is not really my field, but also that should come into the debate. And I'm just taking one point here to stress. Following the logic of integrated area development, of the literature on integrated area development on the social region and other social innovation-based approaches, we think that a stronger focus should be put on bottom-linked governance. And this is one of the major contributions to social innovation research in the last decades, showing how bottom-up practices can change the world on the condition that they are connected to or supported by wider socio-political, socio-economic, wider governance dynamics. Some national and European policies adhere to the same bottom-up philosophy. But in practice, the institutional frameworks applied by many countries, regions, and cities vary strongly and vary in democratic caliber. Policies should work towards more guarantees for the democratic character of local action groups. By some, community initiatives have always been perceived as a correction for an overly market-driven development. Their potential to both democratize and humanize regional and local development is significant. So increasing their scale and examining their relevance for other policy domains, for example, the macroeconomic and fiscal policies, are essential to us. I will end my presentation here. I argued for putting technological innovation and purely economic perspectives in the broader framework of social innovation. Adding to that argument that we need to study community-based initiatives and how they trigger social change and socio-political, socio-economic, cultural, and so on transformation. Thank you for your attention.
Thank you very much, Professor Peter van der Broek, for the sharing knowledge. Now I open the Q&A session. Please, for the participant who wants to ask a question to our professor here, please, you may raise your hand. Yes, is there any questions? Okay, I read in the message in the chat column, there is a Weni Ayu Puja Kesuma. She wants to ask a question. Maybe Miss Ayu may directly open the microphone and ask the questions.
I asked about the slide 16, I guess. Yeah, the policy issues to Mr. Peter.
I'm so sorry, your voice is not really heard clearly. Maybe you can raise up the volume of your microphone, please.
Oh, yeah. Okay. Sorry, sir, can you open at the slide 16 about the policy or issues?
Okay.
Yeah, I don't really understand about the first and the second point of that slide. Can you please explain more about it? I'm sorry, thank you.
Okay, thank you for your question. One of the main points of attention within the social innovation research is that we should not only criticize, as I partially did, criticize the way research is done about economic development, about only technological innovation, but we should look at the initiatives that change this. So to understand social innovation, we look at community-based initiatives, at bottom-up initiatives, of which many examples exist. But there is one condition. These bottom-up initiatives, they are capable of changing the world and making a difference in technology, in economic structures, social relations, and so on, if they are connected to the broader dynamics, if they are connected to the middle class initiatives, to what the governments are doing, to what the private sector is doing. And therefore the term bottom-linked governance comes in. So social innovation or bottom-up initiatives only are successful if they succeed in making that connection to other levels of governance. That's the first point. And we argue that it is necessary to stimulate or to make really fundamental social changes, that governments could stimulate these kind of initiatives in their national and, well, in my case, European policies, could also be regional policies. Does that answer your question more or less?
Yeah. About the bottom line governance, I guess it's like every country in the world facing the same issues about that, because not the upper class person people is really hard to doing some innovation because of their lack of cash or lack of people in relation, or about people having importance role in the governments. Is that linked to how hard it is for, let's say, me to having a kind of innovation to grow in our country because of that?
Yeah, good point. So, well, on the one hand, existing elites, it's not in the interest of existing elites to change the world, because their interest is to keeping it as it is. So we look at local initiatives, because that's where the real change comes from. And if we look at the history, you can analyze how local initiatives, bottom-up initiatives, community-based initiatives, how they have made a change. In the history of Europe, for example, maybe the biggest example is how the unions, the trade unions, have emerged at around 1900. And those initiatives, they started with very local savings groups, healthcare reciprocity initiatives, and so on. But gradually they built healthcare systems, unions, and that created in the end the European form of the welfare state. But indeed, the condition is the local initiatives have to build coalitions, have to increase their networks, and have to make connections to economic processes, social processes, cultural processes. So I agree with your point of view. So it's difficult, but we can see in the history and in our current research that it is possible.
Thank you so much, sir. I'm really satisfied with your answer. Thank you.
Thank you.
Thank you, Ms. Weni. No, I think we have enough, quite enough time to another question. If any other participants who wants to ask questions to our speakers here, we please welcome you. Professor, maybe a question from me. Yeah, we are talking about the social, what is it called? The social relations here. But in 2020, in this year, we have a very bad issues of the COVID-19. How can this situation affected the social innovation from what you studied?
The question of the $1 million question.
Yeah.
Well, we did a small exercise on that with a group of students last April and May, just as a kind of exploration of the connections between the COVID-19 pandemic and social innovation research. So together with 31 authors, we did a collective writing exercise, quickly exploring the internet's literature on that connection. And the finding was more or less that on the one hand, the COVID-19 pandemic confirms the existing inequalities in the world, confirms the power of big corporations, for example, or even increases existing inequities in specific countries. But on the other hand, it also triggered many local initiatives that you could call socially innovative. Solidarity initiatives in the public space, initiatives that changed how people look at mobility, the building of trust through religious initiatives, solidarity initiatives in the economic sphere, going back to the basics of exchange of goods and services, of local exchange trade systems, let's say, replacing even bigger economic systems. So both are, I think, important insights from that small exercise. And I see that confirmed actually in the emerging literature. Is that an answer to your question?
Yes, thank you, Professor Peter, for the explanation. So I open another question from the participants. Maybe we still have any participants who wants to ask the question here? We still have 6 minutes actually.
I should have prepared a longer presentation.
Yeah, I think so. Is there any questions? Okay, maybe after this, maybe someone cannot decide what they want to ask right now at the current time. Maybe after this, if they have another question, maybe at the end of the session, if we still have time, we can ask you again, Professor Peter. So I think, thank you very much for your presentation. It's really interesting for us. And now we can move on to the second presenter, Professor Hiroatsu Fukuda from the University of Kitakyushu. Please share your presentation. Okay, Professor Hiroatsu will present about the methods for wooden of construction, a study on the development of method for wooden construction in Japan. The screen is yours, Professor. Professor Hiroatsu, are you with us?
Sorry, can you hear us?
Yeah.
Okay,
perfectly,
sorry.
Clearly.
I'm very sorry. I will represent myself. Thank you very much for the introduction. My name is Hiroatsu Fukuda from Japan. I live in Kitakyushu, which is the different island of main island in Japan, west side. Today, I'd like to introduce my study about the development of the method for wooden construction in Japan. So I'm not sure the session is really focused on the technological, architectural technological things, detailed things or not, but maybe some of the things which I'm going to develop is really related to today's topic. So maybe it's, I think, interests you. But first, I'd like to tell what I'm going to introduce today. I've been developing the building construction methods for Japanese wooden houses that aim to promote to fix carbon dioxide from the atmosphere and to advance utilization of Japanese shida. Here I introduce some methods of wooden construction which arranges Japanese cedar lumber as a main structure materials. One is a construction method using a typical Japanese timber, 105 3-meter long timber. That is equivalent of maybe American 2x4. We have some standardized timber figures. That is 105 3-meter long. Then examine the construction method, structure planning, and construction technique in an actual project. Then we found the method we used is really fit to make the not normal Japanese building, but more curve form building. So I'd like to introduce that one. Also, this method can be applied the construction using robot techniques. So I will tell that one. The Japanese cedar, maybe you don't know very well, but Japanese cedar is really typical Japanese the tree. We plant that tree 60 or 70 years ago. After World War II, we lost lots of houses. Then we thought that we should have lots of wood planting those infant plants. But unfortunately, the 30 years later, 40 years later, when we construct new houses, the falling timber became very cheap, and we didn't use a lot the typical Japanese cedar. Also, this cedar is a little bit light. Density is not so high. So structurally, it's not so strong compared to the falling wood. So now the 80% of the Japanese wooden construction timber is from other country, unfortunately. Also, one of the problem is the fee for cutting the trees, the fee for transportation of the lumber is also very expensive. Then, unbelievably, to import other countries' lumber is more cheaper than using Japanese domestic lumber, domestic trees. But we feel that to use Japanese cedar is kind of the reduction of the carbon dioxide emission, because if we cut the Japanese cedar, you can put another infant plant. Infant Japanese cedar grow very fast, and it absorb the carbon dioxide. Then they grow. So usually everybody say that if it's the plantation wood we should use, then it's the same. It's kind of a plantation wood we don't use very well. But if we cut those trees and if we put the infant trees, they absorb lots of carbon dioxide, then it reduces the emission totally to the carbon dioxide, carbon dioxide emission to the earth. Then this is the kind of, you can say the absorption of carbon dioxide, demand of the carbon dioxide in Japanese cedar. If it's growing time, they absorb lots of carbon dioxide. But this is the typical Japanese cedar. 105 3-meter long. It's not the timber actually, it's kind of the column. We use this timber as a column in Japanese houses. Then the right side is my method, the left side is normal log house. Usually if we use wood, the log house is more easier to construct. But if we use Japanese cedar like this Japanese cedar is very light, and if there is some weight on the lumber, this direction, it shrink a little bit. So better to use like the left side method. So we call this vertical log house, or the vertically accumulated log house. Then just the method. This is some experimental house, so very small, and only used for Japanese tea ceremony. we made this one with the students. Also, this method is the method of which the student can make, because it's actually just accumulate the numbers. That's all. So you don't have to have some special technique to use the column and the beams. Just accumulation is enough. Then the last time, little bit the connection is difficult. So second experiment we use this kind of a connection. This is the kind of robot techniques. It's the connection which is cut out using the robots, the pre-cut system. Then this is the second version. Then after making this one, we calculated how much this one becomes expensive than normal building of normal houses. Because we use lots of wood, it becomes more expensive. But it's actually we intended, but the cost is more cheaper than normal Japanese wooden construction. We calculated. Actually, the method only. Sorry, this is the percentage, so you cannot compare how much it's less expensive, but only not so large differences. 10% less expensive than normal Japanese houses. But the wooden construction parts, little bit Japanese, a little bit difficult to understand. This is the normal Japanese houses. This one is our method. And the pink one is pre-cut system. We use pre-cut system for connection to make the connection. Then this part job becomes a more larger amount. And this one is this one is the carpenter's labor work. This one is the wooden material, the fee. And actually, we can reduce the carpenter's labor work, and the wooden work wouldn't change so much. Pre-cut system, we have to use lots of money. But this one, the labor fee in Japan is very expensive. The material fee is not so expensive. Pre-cut system, a little bit expensive, but compared to the labor cost, it's not so expensive. So those things, after the calculation of those things, we realize that the method, even if you use lots of wood, still less expensive than normal Japanese houses. Then we try to make more larger one. And this one is another experimental house. And also we made this kind of a house. This one was designed by one of my students. And this became less expensive because material is limited. So we reduce the material a little bit. Between numbers, we put the insulation. And we also made this one only this one is only made by students. Then after that, like this, actually it looks normal Japanese wooden houses, but a little bit different method. This is some experimental things, but just then another student told me, why don't you make the more curved shape, more round shape? And he introduced this one. The method is like this. If you cut some part of the lumber like this, if you use some of the lumber which is normal, or if you change the direction here, the right side and facing the right side, facing the left side, you can make it straight. And if you make only one side, you can make it a little bit round. Then you can change some curve using this method. Then we tried to make this one. And this one. So accumulative method, a little bit more easier for us to make more curved shape, we thought. Then one day, some owner asked me to make some wooden structure. Then I presented these drawings. Why don't you make more round buildings? Because we can make it. Then this is a model. And I wanted to use the method if the student introduced me. But unfortunately, we found that it's a little bit hard to make this one. Then we just made a little bit different method. This is the content is the same. It's a kind of accumulation, vertical accumulation of the wooden lumber. Then most of the part is constructed at the same time. Floors, ceilings, roofs, walls at the same time we can make, because of this is the method. We have lumber structure like this and accumulated little by little, then automatically all the walls, floors, ceilings can be made. Automatically means at the same time we can make this one. Then after making this one, first we were thinking we should make the horizontally to connect to each other, then just make it the vertically. But unfortunately, the field is limited. We knew that it's very hard to make first horizontally, then bring it to the vertically. Then from the beginning, little by little, we put this one. Sorry. Next one. This way. Little by little, we accumulated like this from the right side to the left. From the left to right side. Then we realized it was better from the center to both sides, because to reduce the construction time, we can do both sides at the same time, but it was too late. But it's kind of the result we can get after actual construction. And this is a real building, and there was an owner, so I asked some parts the carpenter, and some parts student made. Those are the students. The student made this one. But inside becomes very interesting for us. But outside, this was covered by titanium. Titanium is very expensive material, but the owner of this building is the owner of the company who produced some commodity using titanium, so it's covered by titanium. Then after that, we try to use this method more larger building. It's the highest part is 12 meter high, lowest part is 4 meter high. Those are some kind of figures. This is a church, but it was competition. Then try to use wood like this, but we couldn't win, so it couldn't be realized. Then we found the same method, the very famous architect in Japan using. This one is done by the Tadao Ando. He is very famous for the concrete building, but he always tried to use the nature of material. So when he saw, this is not the typical Japanese lumber, this is some another lumber, but he saw accumulation method might be very good, so he made this one. The lumber is a little bit different, this kind of lumber. This one also very cheap in Japan. Then he used this lumber as the construction material. Little by little, he accumulated each other. Then he made it this way. This is the plan, the detail. Then another possibility, if you use 105, it's 3 meter long. Also, this kind of figure would be possible. So this is the hyperboloid figures, and this one was done by my Indonesian students. And try to make more a little bit strange figures. this way. And also this kind of a structure also presented other architect too. And also this kind of a method we can use as a accumulative method. Sorry, I prepared so many figures. Then now we try to use robots. This one is not my project. You can find this one if you search in the YouTube. But it's if it's a brick structure, they put the cement like this, then they put this way. You can make this one. But unfortunately, in Japan, we cannot use bricks so much because we have the earthquake, and bricks is very weak for us, the earthquake. But if it's wood, we can use glue. Then if you do this, the wood is more lighter. So if you say earthquake, seismic power is not so strong on each material because each material is not so heavy. Then another, also this is not my project, but another person presented like this one, Australian company did this one. You can see this one also, the YouTube. Then I try to do this, my method. And also if you use this kind of robot techniques, you can do this kind of very interesting figures. And if we make this one only by people, maybe you have to use lots of time to find out the location of each bricks. But maybe robots can automatically place all bricks because it's kind of a 3D printer using the bricks. They actually did like this. Then my method, I thought that you can use the robot for my method. So this is just the simulation. Then figure out the time of the robot. If you use, sorry, this is a little bit strange. I have to show the comparison between robots and the people. Actually, if you use robots, construction time becomes 5 times faster if you use the robots than doing this one by human. And this one meant to be built by robots, but it's not done by robots. It's done by the students. And we try to make the two-story detached house using this method. Sorry, it's almost 20 minutes. Then we did this one. Then we found that maybe we can apply the robot technique for making the normal Japanese wooden houses. Then another possibility using this kind of methods, this kind of lumbers. It's really different from normal Japanese lumber usage. But if you rely on the robot, maybe we have to have the almost same material. We don't have to have many different kinds of materials. So this is just a trial. We don't use any robots, but just we now figure out, is there any possibility you can use robot for this kind of construction. Sorry, time is limited. I would like to introduce my CLT project or other things, but I'd like to finish my presentation. Actually, we are now using lots of Japanese cedar because now you know the global warming is a very important issue all over the world. And European or American or Canada, Australia, they try to use lots of wood as a construction material. So I think now Japan also should try to use lots of wooden material for construction. Then try to use that one more than 30, 40, sometimes 100 years. That means they keep the carbon dioxide inside of the kind of houses, inside of the city, inside of the town. So Those are the things now I'm thinking. I'd like to close my presentation. So thank you very much.
Thank you very much, Professor Hiroatsu, for the really interesting presentation, new knowledge for us. So we use the cedar woods for the buildings, and I open the Q&A session for all the participants. Please, if there's any participants who wants to ask the questions to our professor here, please raise your hand or type on the chat column so I can read for you. Okay, Dwiki Simbolon, can I ask a question? Okay, Dwiki, you may ask our professor.
Thanks for the opportunity. My name is Dwiki Simbolon from Institute Technology Sumatera. To Professor Hiroatsu Fukuoka, I have a question. My question is, why do put a titanium plate on the outer wall of the building?
Oh, thank you very much. The reason why it's titanium is the person who owns the house is the owner of a titanium company. That's the direct reason. But if I use the wood as the construction material, I always cover using some steel or more long lifespan materials. I will give the reason. If you could see this one, it's traditional Japanese tower. Can you see this one? The left side is Japanese tower, right side is Chinese tower. It's almost made the same age. It was built 1,300 years ago. And this wooden structure in Japan is one of the oldest Japanese wooden structure. Then you can see the function of eaves. The eaves eave covers the surface of the wooden structure. The lower side, it's composed of wooden structure. We need to make the building to have long lifespan. We need a very long eave. That means the sunshine or the wind, rain, those things give damage on wood. And the right side Chinese tower, which also survived more than 1,300 years, they made this one using bricks. Bricks, you don't have to worry about so much the deterioration caused by weather, the sunshine or the water, the rain. So maybe that's the reason I want to always use the wood, not showing the face to the air, to the outside. That's my idea. The reason is it should be covered because it's weak. But I show another example. This is my new laboratory, research laboratory. I made inside all wooden structure. We see wood inside a lot. Every part is wood. But outside is also, this is galvanum. Galvanum also survive a long time. So I covered that one using the galvanum. That's a kind of a philosophy of as an architect. I think that wood should be covered by something. If you use that one outside, that's my answer. Is that okay? Doesn't satisfy you?
Yes, sir. So it makes the durable more strong like that. Okay, thank you, sir.
Yes, thank you.
We also have another question here from the chat column. I will read for you. I just curious why importing wood from foreign country is cheaper than cutting wood in Japan. Is the importing wood is also from Indonesia?
Imported wood from Indonesia, we import the falcata. You call that one albasia a lot. Then we use the Albacia as a material inside of the furniture, inside of doors. It's not the structure material. But the reason why we use that one is it's very cheap. That's the reason. And compared to Canadian wood, sometimes the American wood, Japanese wood, more expensive. One of the reasons is Japan, we have lots of mountain. So not so easily to take out trees, lumber from the mountain. It's really complicated areas. So if it's the field, more flat field, more larger flat agricultural field, it might be more easier to take the lumbers. More automatically, you can use some machine to cut the trees or bring it out. But Japan, we have lots of mountain and we have lots of trees in the mountain. And also compared to other countries, Japanese labor cost becomes very high. So that's also another reason. We cannot make the automation system to cut the trees and bring the trees outside. Also, the people's fee are very expensive. Those two things make the Japanese timber more expensive than Canadian or American timbers, sometimes the German timbers. Was that clear? That's the reason.
Okay. Actually, the participant still asking, no, not yes. Asking. I think giving another point of view from him. Okay. Yes. He asked another question, maybe the opinion. Now in Indonesia, it is hard to find a good wood for construction, and that's why we now are using the steel alloy for the construction, maybe for the basic construction for the building. So,
yeah, I've heard that one from the Indonesian students. I told that before, the Japan, the lowest, the price, if you say house, the lowest price is wooden house. And a little bit expensive one is steel house. More expensive one is concrete house. It's the opposite. Concrete, maybe you need lots of labor work, but the labor fee is not so expensive in Indonesia. So he said that bricks and concrete less expensive than wooden structure. I'm not sure it's true or not, but I could guess. The labor cost in Japan is very expensive, so concrete material fee is not so expensive, but to make the concrete building, it's very expensive. And I'm not sure it's clear for you. But I was it's a different story. Now I'm try to use more Japanese cedar, using some technique, some condensed wood, not the condensed wood, this one. This one, I use some heat, this you can see. I compress the wood more dense figures, 1.3 times dense or sometimes 2 times higher dense wood. And it becomes, if you do this, the Japanese cedar, it's not so strong, but it becomes more stronger wood. Then we can use that one as a more structure material than before. I say the labor cost things, but another thing, the Japanese cedar is not so strong. Then I realized that your timber, your falcata, your albacia, also not so strong, more weaker than Japanese cedar. Then if you use my method, this one, you can make more high dense wood, then you can make that one as a construction material. Actually, I just tried to use albacia recently, and I actually find out it becomes really strong wood. So in future, maybe to use albacia more good for our environment. I mean, the albacia grows so fast. They absorb carbon dioxide so much in short time. So better to use albacia in future as a construction material. That's another thing that I'm thinking.
Yes, Professor. correct from you. Your opinion that the building material, moreover the bricks, clay brick in Indonesia is more cheaper than another than wood. Actually, that's correct statement. But single question for me: with this kind of treatment to make the dense wood, is it worth it? I mean, I believe this will gain, this will raise the cost for production of this wood.
Yeah,
However,
that's also a good question. I'm not sure the situation in Indonesia. I'm just studying in Japan. Actually, the wooden production, timber production, also Japan very expensive. One of the reason is the transportation from the mountain to the timber factory. That's one thing. Another thing is in factory we have to make some timber, then we have to dry it up, then we have to cut again. We have lots of process, and you cannot use all trees. You have to get rid of some part of the tree because you have to cut some of the log is round and the timber is square, so you have to cut some part of that one. But if you use this method, you can use all the material. You don't have to get rid of some parts of the tree. So that's more efficiently you can use. And the most important part is you don't have to dry it up. The reason is if you make this way, the water more easily go outside. If you use the timber in Japan, you have to use Japanese system. You have to use 48 hours more than 130 degree high to dry the wood, to dry up the timber. But if you use this one, you have to use 130 steam, high temperature steam for this method. But you can only use that 1 hour, not 48 hours. Then you can make this wood. So it looks more expensive, but compared to the fee to dry up the timber and to cut the timber, this one is less expensive. That's the reason I try to use this one as the method to make new timber.
Thank you very much, Professor Hirota, for your explanations. Actually, I have a lot of questions from me myself, actually, because I'm also working on the material. My PhD also in building material, moreover to form concrete, if you haven't heard about that. So the lightweight material. So maybe it's quite interesting to maybe to contact you right after this, maybe. Professor. Okay, thank you very much for this presentation from our professor. I think we can move to the third speakers.
Thank you very much.
Thank you very much, Professor. The third speaker is Dr. Muhammad Al-Azhar. So, Doctor, please, you can share your presentation slides.
Yeah. We'll try. Hopefully it works.
Okay,
I hope. Yeah. Okay. Yeah. Good. Just want to make it slideshow. Is that clear? Can you see this full screen?
Yes.
Yeah. Okay. Yeah. Yes. So thank you. Good afternoon, everyone. Selamat sore, Indonesia. Here I would like to talk slightly different topic from the previous interesting wooden structure. Here I would like to talk more about marine science, particularly on how implementation of ocean modeling can help and maybe advance the exploration and monitoring of sustainable development marine resources around the world, and maybe as well as possible implementation in Indonesia. So my name is Muhammad Al-Azhar. I'm a research scientist at the Plymouth Marine Laboratory, United Kingdom in the UK, and my expertise is in marine system modeling. I will present some of the works that has been done by myself and marine modeling team at the Plymouth Marine Laboratory, PML, as well as some example of implementation of ocean modeling carried out by my colleague in Indonesia, Ara Hakim. Yeah, so as we are all aware, our lovely planet, the Earth's surface consists of 71% water, where ocean made the majority of those waters, and only 1/3 is land. So that's one of the reasons why we call our planet as a blue planet. That fact is true for the whole Earth, and the percentage between water and land is more remarkable if we look at that percentage for Indonesia. So in Indonesia, we have more than 3/4 of the Indonesian territory is an ocean, and only less than 1/4 is the land. However, how much of this ocean area have been explored? Globally, the number is striking. Only, well, 80% of our ocean is still unmapped and unexplored. And I assume that this number also similar case for the case in Indonesia, considering that Indonesia's water are so complex. As we know, relatively shallow in the west area and the deep ocean in the east. And also there is strong interplay between atmospheric and oceanic dynamic regionally and globally in the maritime continent of Indonesia. Yeah, so there are some ways to explore our ocean. This method that we can use, there are three main ways that we usually use to study and understand our ocean. The methods are first the direct observation, and second is remote sensing, and the other one is ocean modeling. The direct observation is the most fundamental one because it directly obtains the data from the ocean, for example, through cruise campaign or deployment of the instrument. This method normally requires lots of resources and time, and data from the direct observation typically limited in terms of space and time, because the direct observation usually only covers only some points. So this method needs to combine with the other data from the other sources. Remote sensing, this method is similar with the depth observation, but of course in this case it uses the satellite to get the data from the outer space. The advantage of this method is it can cover wider area, but typically only can observe the condition at the surface of the ocean. This method also limited if there is a cloud cover over the ocean, and that's typically the case for Indonesia because we have a lot of clouds. So there's a advantage of and disadvantage from this each of this method. And the third one is the ocean modeling, which is complementary to the other method. The most advantage of using ocean modeling is that we can predict or make forecasts about the ocean condition in the future, as well as to reproduce what has been happening in the past and also what happened in the present condition. The model also offers more flexibility in terms of the temporal and spatial coverage. So I'll be more focused on the ocean modeling here. So let's see few examples of the implementation of the ocean modeling. And before that, I would like to explain briefly what is ocean modeling. So model is a simple representation of the complex phenomena, and ocean modeling is one of the branch of numerical modeling, focusing to represent the ocean physical properties, for example, temperature, salinity, and currents, the horizontal, vertical currents, and typically based on approximated version of Navier-Stokes equation and solved by different numerical methods. The model needs to have a forcing. The forcing is typically from atmospheric forcing, the heat flux at the surface and the winds, and also needs the boundary condition. So one model typically consists of 100,000 lines of codes, and usually written in Fortran code, and for high computation requirement, we need to run it in the supercomputer. And the model can be implemented to idealized or to realistic condition, and also coupled to other model. So this is the example of implementation of ocean model that I would like to present here. There are 7 implementation that I would like to share today. First one is operational modeling, and then implementation of model for marine aquaculture, and coupled to ecosystem model, and also how the model can track the event of oil spill, implementation the model for renewable energy, and also to track and monitor the microplastic transport in the ocean, as well as to monitor and predict the algae bloom. So yeah, this is the first one. The first implementation is the operational model. So the core of operational model is a hydrodynamic model, which provide estimation of temperature, salinity, and currents and waves condition in the ocean. The model fill the gaps in observational network and provide past, present, and future condition. The operational model can be implemented into global and also regional scale. For example, on the top left is the example of EU-funded operational model hosted by Copernicus. It is freely accessible for public. It covers the whole ocean with the intermediate resolution of 9 until 10 kilometer resolution, each of the grid. So on that top left, it shows the sea surface prediction for 28th of October, so a couple of days from today. And on the top right, this one is another example of operational model that I was developed for the Persian Gulf with slightly higher resolution because it has more feature along the coast. So here I modified the resolution into 3 kilometers. And on the bottom figures is example of operational model hosted in my institution for UK domain, and it has slightly more advanced grid configuration. We have variable resolution, for example, 1.5 kilometer in the coastal area and 10 kilometer resolution in the open ocean. So higher resolution in the coastal area is important because it can better resolve the dynamic and variability of the ocean properties, the temperature, salinity, and other oceanographic properties along the coast. So yeah, next example is how we can couple the model into other model. In this case, we link the hydrodynamic model into ecosystem model. On the left panel is an example of map of surface chlorophyll in the UK, around UK waters. So we coupled this with our own ecosystem model that developed in our institute called ERSM. The model simulate multi-type of plankton, nutrients, and also simulate the oxygen, as well as simulate the carbon cycle. And on the right panel is another example of the coupled model. It shows the ocean productivity in winter and summer in the ocean, in the Indian Ocean. So the figures show seasonal variability, which may important for fisheries and for any other ecological purposes. So yeah, and the third one is example of combination between two methods, remote sensing and ocean modeling, in identifying and tracking harmful algae bloom. In this case, is implementation for in the Persian Gulf. So harmful algae bloom is an event where some sort of toxic algae grows exponentially in the ocean due to many reasons. Typically because there are more food available, more nutrient for them to grow. And this algae bloom can be problematic because large bloom consume oxygen, therefore reduce oxygen consumption in the water, creating hypoxic zone, which can deadly to fish and other organisms. So, there are several examples of similar case as covered by Indonesian media here, especially in Jakarta Bay, and possibly similar case in Ambon Bay recently. So in the top panel, satellite data provide estimation of area where the bloom occurs, and then from that information we give that information to ocean model. In the bottom panel, the ocean model then predict the movement of this dispersion. From the model result, we can have important information, for example, for government or any stakeholder to know how their coastal region are impacted or not by this algae bloom. So this is the example of how the model can predict the movement of chlorophyll-like particle in the ocean. The movement of this particle are simulated based on the advection of the current velocities. In this case, as soon as the satellite detect there is algae bloom happening, that information feed to the operational model, and then the model simulate this prediction in the real-time condition, so we can share this information as soon as possible to the government, for example, to take further action if needed. The fourth example is the oil spill modeling. This is example again in the Arabian Sea, but this implementation can be implemented in any ocean waters, for example, to predict the movement of oil spill, which happened recently in Indonesia, in Teluk Karawang. So similar to the case of algae bloom, so satellite data detect some patches of the oil spill in the ocean, and then based on that information, we run the model, and the model then produce information where the spill will go and how dispersed it is, and this information is most likely important on how to conduct rapid response in handling the oil spill. So the oil spill can be localized or predict how far the spill can reach the coastal area. This is an example of a gasoline type oil spill that I modeled offshore of Abu Dhabi region in the Persian Gulf. So the arrows shows the movement of the currents, and yeah, that red patches is the gasoline type. So because it's a gasoline, it evaporates more quickly, but we see the remaining also reaches the coastal area. The next one it is an example of modeling the microplastic in the ocean. So as we are all aware now, microplastic is a new emerging pollutant in the environment, and it suggested most of it to be ended up in the ocean at large basin scales. For example, in the Atlantic Ocean, the plastic are known to stay and circulate around the subtropical gyres. But recent observation found that the plastic concentration are 10 times less than expected. So there must be some significant portion of the plastic that lost in the ocean. One hypothesis is that maybe marine organisms eat that missing fraction. So here in PML, we try to partly answer that question and tested that hypothesis. So we coupled our model with a particle tracking model that represent the transport of plastic. And the result can be seen at the bottom figures on the bottom right. So these figures shows how the microplastic distribute around the water. And the important result from this modeling works is that the model gives information where to take the sample of potentially high microplastic concentration in the ocean. And as soon as we identified that location, we went there by boat and we took the sample, we bring it to the lab, and then we process. And indeed, we found that we observe the marine organism, in this case is zooplankton, inside their body. We find some fraction in some fraction of the plastic in their body. So this is example of how model can help with combined with direct observation to tackle the emerging pollutant problem, in this case microplastic. The next example is how the ocean model can help to assess expansion of offshore aquaculture. In this modeling study, we coupled the model with a fish model that based on net energy balance between the growth of the fish, the death of the fish, and the reproduction of the fish. Here we implement the model to rope cultured blue mussel, one type of fish with a shell. So we try to assess the economic and environmental impact of expanding from only have one side and into 3 sides. So using the model, we try to predict the both carrying capacity in terms of the production, the economical carrying capacity, as well as the ecological capacity. In the top left figures here, the model results suggest that this area actually has adequate food for the mussel. So it is possible to expand from one side to 3 sites. And in the top right figures, the model shows that the location of the additional sites are also relatively good because the area is sufficiently dispersed, so there is enough natural flushing for any sinking organic material from each of the sites. The model also able to predict the growth and production of the mussel as we expected. And in terms of the ecological impact, the model suggests that the feces or pseudo feces from the aquaculture site will drive the oxygen consumption in the water column and also in the bottom waters. The oxygen is one of the key indicator of the quality of the ocean. So if we have less oxygen, that means the ocean condition is not that healthy. So using this information from this coupled model with the fish model, we can assess how the expansion of this aquaculture is sustainable or not, environmentally and economically. The last example is implementation of ocean model to assess the tidal power energy in Indonesia. This is a work done nicely by my colleague in Indonesia, Ara Hakim. He configured and run the model for Larantuka Strait in East Nusa Tenggara. He able to map the location and predict how much energy can be obtained, can be harvested from the tides, convert into electricity. Here, the model result clearly show that it really helpful in identifying and assess the potential location. Indonesia has lots of narrow straits with relatively high tides and strong currents. The implementation of this similar study will be really helpful in finding and eventually convert the tidal energy into electricity in Indonesia, especially in the remote islands where the conventional or traditional electricity resource is limited. Yeah, that's all from me. So any question, feedback, really welcome. Thank you.
Thank you very much, Dr. Muhammad Al-Azhar. I open the Q&A session for participant who wants to ask the questions. Please raise your hand or just write down the question in the column chat. Yeah, is there any questions? Any questions? No. Okay, Dr. Azhar.
Yes.
This model actually is really important for us actually in Indonesia because we have really large of coastal area, so we have really much nature resource in our ocean. So has this model already used in Indonesia or other country actually?
Yes, it has been applied into various locations around the world, as well as in Indonesia, because actually the model is an open source model, so you can download and you can also run it freely, so it's available to the public. The most important factor is that you need to have expertise and also willingness to run the model. But of course, for the case of Indonesia, it's really helpful if there is like some issues environmentally, or for example for the marine aquaculture. It's really expanding in Indonesia, and I believe that the marine ministry in Indonesia, they also have some similar modeling, but in terms of the continuity of the model implementation, and also the availability to the public is still limited. So yeah, there is clearly lots of potential to be implemented in Indonesia, as you mentioned.
Yes, said that this application is freely downloaded from the internet, but you mentioned before the reader, I mean the one who can read all the data is limited. So how can our public, not the government, our public, said the fishermen said not really what is it called? Not the high level of social, the society can get this data actually.
So the model itself is maybe kind of core tools to produce the information. So we have another step is how to disseminate the information from the model result to the public. In this case, I think it already, I think it's ongoing development in Indonesia and around the world. It's how to map or give the information as simple as possible, so it can be it can be read and understood by the public easily. For example, we can take the example of the weather forecast. So today, for example, in Lampung or in Jakarta or in Bandung, in the next several hours we will have rain. So that's it. That's the simple and information. From the ocean model perspective, we can give like updated map, for example, daily or sub-daily into fishermen, and then just give a map for potential where to get the fisheries. I think that's the practical thing that been carried out in several countries. I think in UK, in European countries, and as well as in Japan. I think that's really common happening.
Thank you very much, Dr. Azhar. Yeah, I hope this application can be applied for the public as soon as possible before all the fish in the ocean finish, right? Okay. And also, I think in Japan also needs this application, I guess, right now, right? Professor Hirota. Okay.
I think you are muted. I think, Professor.
Sorry, I don't know the situation very well, but maybe also the same situation in Indonesia. We have lots of ocean around the country, so it's very useful, I feel.
Okay. Thank you very much for all the speakers. And we have another question for Professor Peter. Is Prof. Peter still with us?
Yes.
Yeah. Okay, Prof. There is a question from Kintarani for you, actually. I think I will read it. Okay, related to your presentation about policy issues, point number 3 about redistribution, can you explain a bit about how lacking in macroeconomic affect this redistribution for technocratic policymakers? Even though, as you mentioned, that it is not your field. Okay, thank you.
Mm-hmm. Yes, I saw the question. Thank you for that.
Okay.
The starting point of this slide is the writings of Karol Polanyi, so who made an analysis of a history of 200 years of history of society, actually Western society, since the Industrial Revolution, and he saw that gradually the Industrial Revolution caused a marketization of society. So not just we didn't just develop markets to exchange goods, but also to exchange people and to exchange nature, commodification of land, commodification of labor. In response to that, in the middle of the 20th century, large encompassing welfare systems were developed, in which redistribution played an important role. So it started with, that would lead me too far. Anyway, it created healthcare systems, educational systems, taxation systems, and redistribution of money was just a big part of that. The argument today is that we are in a new stage of encompassing marketization since the 1970s, which is not just Europe but global, and that there is a need to reinvent that idea of redistribution. So taking money from the rich and redistributing it to the poor, well, it's much more complex than that, but let's simplify it in such a way. And social innovation initiatives could play a role in that by reinventing redistribution systems very locally, and then gradually upscale these to a more wider social transformation. There are many examples of how local communities reinvent local currency, for example, about the new ideas about cooperative banks, other examples that in the end may lead to a more fundamental social and macroeconomic change. Is that a bit of an answer to the question?
Thank you very much, Prof. Peter. I think Kintarani has already get the answer, but if still needs another explanation, you can ask directly. Okay, another question for Dr. Azhar, actually. You have been successfully modeled the ocean coupling with some models. How is the model validation? Okay, model validation, and how demanding the model to our system?
It's because I have limited time, only 20 or 30 minutes to present the result here, so I don't give much detail into the model validation. But what I can tell is, it's not too bad. The validation of the model, we can say it's acceptable and reasonable. But of course, it's not as perfect as we would like to expect, because there is uncertainty and limitation in the method and in the approximation. But in general, when we run the model, we validate the model, and once we agree that the validation is good, then we move to another step, which is coupled the model with other modules. Otherwise, we first need to validate the model into some degree that we can accept. And in terms of how demanding, well, it depends on which implementation that you would like to. For example, if you only would like to run the hydrodynamic model, you can run it in your own or private personal computer PC, but of course it's a bit relatively slower than if you run it in a cluster or supercomputer. It's still doable, but in terms of the cost and how the willingness for you to wait the result, it depends. So yeah, it can be really demanding, but at some point it can also be really practical. Yeah.
Okay. How about the answer? Maybe Mustara, is it okay with the answer, or you want to ask another questions? Okay. Okay. Thank you very much. All right.
You're welcome.
We've come to the end of this program. Okay. I thank you. I really thank you for our plenary speakers, Professor Peter van der Broek, Professor Hiroatsu Fukuda, and Dr. Muhammad Al-Azhar for your really interesting information. We get really much knowledge today. And I would like to remind you, all the participants, that tomorrow morning we still have another plenary speakers at 9 o'clock a.m. and continued with the parallel session at 10:45 a.m. in the morning. So I think we can end this session. See you in another next session, maybe tomorrow if we still have another time. Okay, thank you very much for the speakers. Thank you very much.
Thank you very much.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon.
Good afternoon.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Thank you.